Okay, my name is Steve Whaler. I am a professor in the Department of Human Ecology. I am chair of the Community Development Graduate Group. And in 2022 was the UC Davis Faculty Sustainability Champion. We are joined today also by Mark Husing, who's the 2021 Faculty Sustainability Champion and co-convener of the Fossil-Free UC Davis group. And what I want to talk today about is activism, getting UC off fossil fuels. You will not learn about activism in most of your classes. In fact, it is seriously frowned upon by most in academia. But with the climate crisis and with many other crises, we need to think outside the box, and we need to challenge institutions and systems and ask for fairly dramatic change. This is the way all great social movements happen. It's not through careful studies, it's through people challenging institutions, systems, calling for structural change. So across the UCs, we have a group of maybe a dozen faculty across the whole of this huge 10-campus university system who are really active leaders on the climate crisis, calling for the system to be fossil-free. As far as I know, I am the only person, faculty or staff, from the Energy Graduate Group who is part of this movement. So I invite you to join, and I'm going to try to provide a brief history of some of the things that have gone on, and then we can have discussion. So I think I introduced myself. I'm not going to go into great detail on that. I think you all know about the climate crisis. We have an image of Greta here. We all need to have her courage and step up, right, and do stuff. There have been activists across the UCs doing this for over a decade now. In 2008, we organized a campus-wide teach-in called Focus the Nation, which was the result of a campaign by 350.org, the group founded, I believe, by Bill McKibben, to call attention to the need for climate action. And we had a day-long teach-in here. The chancellor was involved. The campus planning office helped organize it. Not much happened. We had in the teens, in the 2010s, we had a campaign across the UCs to get the UC to divest from investments in fossil fuel stocks. And that was successful, finally. We had students picket the Board of Regents. I personally helped do that at times. We had lots of organizing. We had votes by student associations, by academic senates, and eventually by the entire university faculty, asking the regents to divest. And in 2019, they agreed to do that. They said that activism had nothing to do with it, of course. They were doing it just for business reasons, but I think we know better. There still is probably some distance to go in this regard. UC still invests in some companies that deal with the oil industry. It still has its money in banks like Wells Fargo, all the big banks are financing fossil fuel to the tune of trillions of dollars. We've got to get the UC to rethink those investments and to bank with socially responsible institutions. We have the Carbon Neutrality Initiative that many of you know about, which was launched in 2013 by Janet Napolitano, and who was president of UC at the time. It seemed like a great idea at the time. It was a great idea at the time. We had workshops on all campuses around climate education. The idea is that we would get climate into classes all through the disciplines. These are faculty. We had a couple workshops that I organized on this campus, and pretty good turnout from faculty, pretty high level of interest. But it became clear later that in order to meet the target of being carbon neutral by 2025, UC would not actually be reducing its emissions, it would simply be buying massive amounts of offsets. And offsets have many problems that I won't go into, but there was no plan for reducing those, and so the goals switched. at the end of the 2010s to ask UC to end use of fossil fuels altogether. People at UC San Diego and few other places initiated a system-wide petition in about 2020 asking for more action. And over 3,300 faculty, students, and staff signed that, unions. Organizing increased system-wide, and we started during the pandemic, partly due to Zoom, being able to get together system-wide more easily for organizing meetings. And we worked with the system-wide academic senate, which actually was in support. And last year there was a vote of faculty across the system calling on the regents to commit to reducing emissions 60% by 2030 and 95% by 2035. Also at the time, there was a Green New Deal coalition developed across the UCs. Again, a fairly small number of people, but trying to think holistically based on events that were going on in Washington at the time. How do we really have a sustainability framework for our university that deals not just with climate in isolation, but all the social and economic dimensions that are tied to that. And that is very much still going on. UC Davis, during all this time, has done a fair bit. West Village itself was a major achievement, even though it is not zero net energy as was promised, and the university has stopped trying to make it zero net energy, unfortunately. There were various technical problems. There are some design problems. Some of my friends call it the gulag out here, but nevertheless, it was a bold attempt at the time. There's been various solar, there's been academic achievements. A bunch of us got together in the mid-2010s and got a climate science and policy minor going. We would like to have a climate science and policy or climate action graduate elective, which would be like a minor for grad students, but there simply are not enough grad courses. There are very, very few grad courses on moving to a carbon neutral society. And so we don't have enough courses to do it. Hopefully that will change. In 2021, some of us faculty formed a loose organization called Fossil Free UC Davis. We held a petition campaign, got 1,300 signatures, went to Gary May and asked him to take action. He directed the staff to prepare a fossil-free plan by 2022. Staff did launch that, but for reasons that escape me, has been unable to complete it. And if anybody knows why, let me know. But we hope that the university can in fact step up and be a better leader. Yeah.
Yes, but what staff specifically? Like what department?
The effort is being led by Camille Kirk, who's the campus sustainability officer, and Jim Carroll, but it's mainly Camille, I think. And unfortunately, the incentives for staff are usually to do enough to make the university look good, and not necessarily to actually do what needs to be done. So as one of our senior staff once told me privately, we do just enough to brag about. So if I come across as a little cynical, I'm sorry, but let's face it, we need to all push quite a bit more to make stuff happen. This is why we need to push. Activists got this data under a Freedom of Information request in the late 2010s about actual campus emissions across the UCs, and they're not going down. Most of these emissions are from the central heating and cooling plants, and those continue to roar along, and we basically have to replace those.
We have an online question
Yes.
regarding that. Are refrigerants included in these scope 1 emissions?
Yes, they are, but they're a very small portion.
Yes, it is almost all the central heating and cooling plants. This is a pie chart showing that, well, this is a few years old now, 2017, but about 2/3 central plants, 30% purchased electricity, and then everything else is minor. Transportation is minor. It's about 4% on this campus. Yes, we should buy nothing but EVs from now on, but let's face it, it's not that big. So this is the biggest challenge. We of course need to do efficiency improvements. The university will be trying to move to biogas as a transition fuel, which I'll talk about in a minute. And we, of course, need to do lots of and we need to electrify everything. You all know that. And of course, we need to, all of us personally in our homes, in our offices, need to, and our eating, we need to do what we can. Just a couple days ago, we have the next step in university decarbonization policy coming from the Office of the President. And Mark may be able to say more about this than I. There have been at least one draft, maybe more, floated for the last 6 months because there has been pressure on the president of the university and all the chancellors to do more. And so they learned that, okay, offsets are not going to fly, we'll need to move to something else. It's not enough, but it's a big step forward. It is 90% by 2045 relative to 2019. And they included scope 3 in it, which is great, which is, everything external, our travel to work and conferences and other things. And there are every UC campus has to purchase 100% clean electricity in 3 years. I do not want this. Every UC will have to do a new climate plan. Every UC will have to start paying $25 a metric ton for its emissions after 2025. So there are some good pieces that are being gradually put in place, but it's not nearly enough. We will continue to burn methane in our present ways for some time.
Is the carbon removal refers to engineered carbon removals in this direct air capture or more nature-based solutions like forestry projects?
I assume it's both. I don't know detail on it, but I assume it's both. And certainly we're doing lots of research into the latter here. The state of California is also hunting on climate action to some extent by weighing carbon removal very heavily. And I don't think that's entirely honest on the state's part, but that's what they're doing. Okay, there is a protest letter. There's a link at the bottom. Many of us have protested multiple times this policy and asked for it to be stronger. But this is where we are going. And
Just to add to this, some of the things on Steve's list here, for example, the 2019 baseline, the original policy was 2009. So they were basically taking the policy like 14 years in the past to be able to tout the emissions since achieved towards the future goal, which just makes no sense. But Davis hasn't done that. Davis has always done 2019 as baseline, which is honest. And the rest of the UC is now coming along. That was in direct response to a bunch of us pointing out the obvious. And that does make a difference. So there were good changes made. The biggest problem is they're still working with 2045 deadline.
okay, so where we're at, we have some challenges. We have a basic planning challenge. Can we move quicker? And I'm hoping that we can actually have increasingly competent work being done on this. Can we improve transparency? The UC Davis is not very good at transparency and at letting people know how the planning is proceeding. Some people are great, but overall not the best. How can we engage each other, faculty and staff and students? Cost, of course, but I would like to point out the bottom graph, which was a study that UC Davis did in about 2017, when it knew it was going to have to replace all the old steam lines on campus, about long-term costs. And you save money a lot in the long term by electrifying. Probably if we did this now, it would be even better. Continuing the old system would have been the most expensive option. So somehow we've got to figure out some creative green bonds or something or other to capitalize a long-term operating savings up front, which is a problem with many energy fields, as you know. We also need to be very active politically with the state legislature around state money and get some of that federal money that's coming down from DC. The Office of the President is giving $1.5 million to each campus roughly to do further planning around eliminating fossil fuels. And it's not clear at all what Davis is going to do with its part. But we need to leverage much bigger sums. It will be, billions system-wide. And then we do have a problem with conflict of interest also. We have a lot of institutions, a lot of UCs get a lot of fossil fuel money. Berkeley's actually about the biggest in the country. And this institution does too. And so people who, just like with tobacco or with alcohol or other industries where, academics study and also get grants, we need to, and with pharmaceuticals, we maybe need to put some distance between those two. So that's kind of all I have. I invite you all to step up, to talk to Mark and me later, or and to help us organize getting UC really into a global leadership position on fossil fuels. So thank you all very much. That was the time I had, right?
You open for questions.
Okay. Yes.
Is the $25 per metric ton an internal carbon price then, essentially?
I don't know details. I assume it is. This is money that would go to UCOP and be redistributed to certain programs. And I think the programs are both actual reductions or basically offsets that we create. And there would be an emphasis on, UC created stuff. And there's some climate justice investments in it.
So what happened was UC system-wide saw the massive offset bill come to, they know full well that most offsets are really, they might be doing good things socially, like for example, purchasing cook stoves in sub-Saharan Africa genuinely is with health benefits for folks who see that quality of life improve a little bit. The notion that the big UC can just offset their emissions, and I mean, that notion is, I think, morally very problematic, and it doesn't actually do anything to reduce greenhouse gas emissions on our side. So UC realized that they knew it was untenable, and they saw the bill that they themselves committed to. So instead, what they said, look, let's just do away with that, and let's direct some of those funds to actual additional decarbonization of our own emissions, which is good. And I think most of us would much rather see that money put towards actual decarbonization. Now, the $25 metric ton is not the actual cost of the damages. Like, so UC-wide uses a $246 social cost of carbon, meaning that's the monetary amount of the damages that somebody's picking up as a result of our emissions. And there's a big gap between 25 escalating to $5 annually to what, for example, UC Berkeley, UC itself will use internally. I think that social cost of carbon would be a good policy instrument to try and make the math work for, I think, folks who are stuck with having to justify, for example, doing something with long-term emissions reduction benefit that doesn't price out in the beginning. And I think that's what we're moving towards. We would love folks like you who are thinking about these things to actually participate, because these discussions on this campus have been mostly devoid of folks with actual expertise in this space for reasons that and this is true for many things that campus is doing, where I wish we would tap in more in the existing expertise of our own campuses, both at the student level and faculty level. Because right now it's been basically 2 faculty members who've been providing much of that feedback, including myself, and I have no background in this traditionally. It's not rocket science, but I mean, you guys are all very much, get in touch. I think it would be very helpful to have in these ongoing discussions, have folks whose professional training expertise really bring something additional to the table. I've connected people in these graduate groups to really good professionals on campus and had them have conversations about embodied carbon in concrete, for example. Just the opportunities are there to really help our campus.
Does the Energy Conservation Office not participate at all in this, like Josh Mordon and?
Josh is doing great stuff with the shift, and
Josh is not directly involved, but
he is not setting policy.
But Camille and Josh talk, and Josh's colleagues have been involved.
What's in place to like sort of audit and say that we're staying on track for even what we're saying we're going to do?
Well, the university, like any large institution in California, does have to prepare emissions inventories. I can't remember if it's annually or biannually. And presumably that would do it. I think there are additional inventory requirements in this new policy that is just out last week. I'm not that worried about that. What I'm worried about is the policy change. You all are learning lots about science and technology in the energy grad group. But what's going to make the difference is policy change, and advocacy and activism to change the institutions. Then, okay, science and technology comes in, but we need to really demand that UC lead, and that this campus actually finish its climate plan that was promised 4 months ago, that it commit to reducing emissions 90% by 2030, which is what we asked Gary last time we met with him. That it write off its 15-year-old cogen plant at Aggie Square in Sacramento, which was unfortunately a not very bright decision, and electrify everything.
For the scope 2 emissions inventory accounting, does UC use an hourly emissions factor or an average annual one, such as from eGrid?
I don't know.
That's a good question. I have no idea.
Yeah.
Sorry, to answer your question, there's no consequences to not meeting these policies. Like, we are utterly failing to meet carbon neutrality by 2025, and there is nothing guaranteeing we'll meet these unambitious policies UC-wide. And UC Davis kind of come out with a 15-year fossil fuel-free plan. I've seen it, I'm on the committee. That I think has many good things that will really benefit from a bunch of folks with knowledge and expertise to really say this is wonderful, this is great, and here's how you can further improve it. And there are things in that plan that are going to be just pretty pedestrian that I think we can do a lot better at. And I think there too, there's a role for all of us to kind of play and provide that feedback. And I think there is a bunch of staff on campus, I mean, that are genuinely doing good, have had planned for years, and all they need is folks like us to kind of chime in and support and advocate, because it makes their job easier.
The main type of offsets that UC is thinking about at the moment are funding cook stoves in Africa. It's great to supply poor people in Africa with better cook stoves, but to use that as an excuse for not taking action ourselves on the world's biggest environmental problem, when we're the richest public university system in the richest state in the richest country in the world, is kind of morally indefensible.
I'll throw out one other thought. I don't know if you've considered it at all. One of my struggles is I just have limited time to decide how I'm going to advocate, what I'm going to advocate for, right? Like it's like, oh my gosh, you wake up every day and like, what's the most important crisis you're facing? So one of the struggles for me, I guess I haven't like answered this exhaustively, but I think if we look at the data from it's really the residential housing that's burning most of the gas for heating.
Well, if we look at the data for
Yeah.
the city of Davis, it's 70-some% cars. You know, cars are far and away our biggest source of emissions.
Okay. But I mean, I guess I'm a building scientist, so I think mostly about buildings, like what's the problem
Yeah.
I'm going to solve, right?
Yeah.
And so it seems that just because the way that, you know, that commercial building heating, but residential heating demand far outweighs commercial, because I think mainly because of how houses are built, they have such a large perimeter area.
Yeah.
So it's just, obviously we can have an impact on what UC does, but having gone through my own recent electrification experiment, I've been thinking more about advocating how to make it easier for homeowners to deal with their problems.
Yes, one
Landlords.
of the things I proposed to UCOP was that it use some of the offset money to provide technical assistance to faculty, staff, and students who want to convert their homes. Because it is hard to know how to do that, and they didn't buy that. But,
Well, maybe we can talk at lunch, but there's some very, since I've gone through the process of not even having even finished, there are some huge roadblocks that get thrown up in front of you.
I know, I've gone
So,
through the process too.
Yeah,
Yeah.
yeah, so it seems like if you have any extra
But
gas in the tank, that's for, you want to advocate further, right?
Bad analogy.
No, it's a good analogy.
No gas in the tank.
Right, no.
Juice in the battery.
Also, the city of Davis just did a climate action plan, and you know, prohibiting any future installation of fossil fuel infrastructure, including home HVAC systems and hot water
But
systems.
didn't the one in Berkeley just get struck down by the port?
It
So the
did,
one in
and we
Berkeley got
have to get
struck
around
down.
that.
One in Berkeley got struck down because it was added under the health statute of their code. Most of the other gas bans are built in the building code, when those are all just unaffected by any of that. So the Ninth Circuit ruling against Berkeley is not nearly as broad as,
As it might seem in the
Yeah.
news.
yeah.
There will be obstacles at many levels. We have to figure out ways around them. As far as what we do with our time, I don't know. I personally just look for little strategic areas where a small bit of difference can maybe change something. How you find those, I don't know, but we can collaborate on ways to do that. Right now, there is one coming down for the city of Davis because the city has 6 different proposals from developers to radically expand the size of the city. And there is a new coalition starting called Davis Can. I believe that stands for Climate Action Network. But its agenda is both climate and housing. The inaugural meeting is this Sunday, 3 to 6 p.m. at International House, Russell. And they and we will be working with members of the council and others to try to get a better housing framework, which in turn will hopefully lead to climate advantages.
Just from a higher level, when I'm thinking about it from the UC standpoint, what is the biggest challenge to decarbonize or climate action? Is it like the not understanding the urgency for climate change? Is it like there are no solutions, or is it money?
The biggest challenge is leadership, both leadership from the top and from the mid-level staff, as we're seeing on the climate plan right now, and leadership from the bottom, which means all of us. Money, we have lots of money in this society. It's just going other places. You know, there's no lack of money. We need to organize to get enough, you know, and we do organize around many things. UC has, you know, tens of billions of dollars thrown through it every year. So it's leadership. And this is something that the university occasionally talks about encouraging in its students, but doesn't do a very good job of. So I would encourage the Energy Grad Group, which I am a part of, and every other to prioritize. And leadership means developing visions of things that are pretty different, seeking structural change, questioning big picture systems, and actively connecting research to change, which academia is abysmal at in general.
Great, thank you for your time. We're gonna go ahead and switch presenters. So for those of you online, just give us a quick moment.
Sure.
I forgot you were presenting. I wouldn't have had to ask that question.
Sure. I'll give it a try.
Go
If I
ahead
need-
and get your PowerPoint photo.
Oh, look at that.
Oh, Stacy.
What you brought? All right, everybody hear me okay? So I think Professor Vijay set up pretty well for me to go into this with, and specifically what I'll be focusing on is building decarbonizations with heat pump. So let's just get into it. So space heating, which is the most used carbon in a building, is usually done with furnaces. And today I'll be talking about heat pumps. So what are heat pumps? I'm just trying to set the stage up here for people who are not very familiar with it. So, and the focus would be on air source heat pumps, which is a particular type of heat pump. And the idea here is that we have, over the summer, the heat pumps work like an air conditioner, which you all should be very familiar with in our houses, is that it delivers cool air, takes in warm air inside the house, and it throws out the warm air on the outside, even when the outside is hot. And in the winter, the heat pumps is what is the reversible air conditioner. It just does the opposite. It takes in cold air inside and dumps hot air. And on the other side, the outside, it dumps in cold air into the already cold environment. And one of the terms that would be used, I guess, later on is COP, which is coefficient of performance, which is basically nothing output over input, is the heating or cooling energy that is provided by the heat pump over the electrical energy input. And in most cases, it pumps like an average of, that's why I have an approximate number of 3 there, of heat pumps that are better than that and lower than those numbers available. And so the big key is that heat pumps can do cooling and heating, but it uses electricity as its input, which is in some sense it's a better form of energy than heat. Gas furnace, which is what we typically use conventionally, and as Teresa was just mentioning, that houses are pretty much heated by gas furnaces all around the US, and they use natural gas as the input, and you burn the natural gas and get some heat out of it. Usually the average that I was mentioning about COP, the heat energy output over the natural gas energy input, is around 80%, and at max it can go up to 96% for the natural gas we are burning. So what the study that we are doing here is that what we are trying to figure out is that, does heat pumps really make sense? And so is basically, and what we are trying to see is that there's a fight between furnace and heat pump at different building and types and conditions and climates and usages. So taking a step back, so what is our motivation here? And I think we have seen a lot of action from the government at state and federal level that the electricity sector needs to be decarbonized, and it is decarbonizing. Maybe slower, but it is decarbonizing over time. That's not the case with on-site emissions that I just mentioned from especially natural gas burning in buildings. And that goes from in residential, which is a larger amount, it's about higher than commercial buildings, but there it has been pretty much constant over time. And there is a need for decarbonization in buildings by trying to move to heat pumps, which can offset the on-site emissions. However, the heat pumps can add grid emissions, which can near term increase the overall emissions. So the question that we have been all asking for some time is that, are we really reducing overall GHG emissions from heat pump installations? And some people ask oh, there are refrigerant emissions in there. There are other things like natural gas leaks. So overall, are we really making the cut? So to answer that, we have developed a study methodology, which we have used in the past. And what we do is we use energy modeling of buildings. We do a building model. We do the HVAC design and sizing in Energy Plus, and we get the hourly zone loads. We have used different building zone aggregation, and we use an NREL Cambium data set, which has been published, and they have updated it very recently too, which categorizes emissions by end use. So how much end use of energy that the electricity grid is emitting from the energy that is being used at the end. So we use the Cambium data set, which is available to everyone. It's open source, and you just get the data, and we use something called a long range marginal emissions, which is basically like how in the longer run, if heat pumps are installed, the marginal emissions are going to change. So we have used that, and we calculate yearly GHG emissions, and we develop some visualizations to show this and see the regional impact, because it's a lot of data, so we just put it into regions. And the first instance of it is we did it with the residential home that Teresa here led, and we have so to set this up for all the building types, I think it is important to talk about this one specifically, because as I've shown, residential buildings are the highest emitter for emissions. And so what we have done is this energy plus modeling of 2-floor residential home with a total floor area and fan efficiency, as you can see, and it uses a gas furnace and one split heat pump, which is usually homogeneous, like usually the case in a lot of homes in the US. And so we modeled that, we simulated that across different cities. 99 cities were simulated across 6 different regions in the United States. And we aggregated the results by the county population back into a region. As far as the equipment goes, we had simulated a condensing gas furnace, as I had said, they're the best in the class with 96% efficiency or annual fuel utilization efficiency, I think. So that's like the best you can get from a natural gas furnace. And we compared it to a variable speed heat pump, which is with the COP of 3.0, which is, I think there are better ones in the market, there are worse ones, but that's the one we chose. We have, and you can see the COP curve here, and the top and the bottom shows as it's a variable speed, the highest speed and the lowest speed there, and the capacity also. This is where usually the heat pumps are rated at, so that's what is usually shown on the label of a heat pump. The part that is kind of interesting to this study was that we also modeled the supplemental heating, which some studies have missed and only looked at heat pump. So if the heat pump is unable to provide the load, the supplemental heater kicks in and provides that load, which was not able to provide, which is not able to be provided by the compressor. So if the capacity is low and the house needs more heat, the supplemental heat kicks in. And then there is a point where the compressor cannot, the heat pump is not able to keep up, and the compressor has some sort of point where it's not able to operate, and we put a number of -18. It could be, there are some numbers and again, it's kind of an average, we took a number. Where the compressor shuts off and all the heat is provided by the full electric resistance heat. Just going over quickly, we also included annual refrigerant leak emissions using some expression we had formulated, and then we also included the GWP, 2 different refrigerants. So one is a high GWP refrigerant, which is currently in use and being installed, and later on, due to regulations coming up, I think it's 2025 is coming up in California, but is moving to a GWP refrigerant less than 750. GWP is global warming potential of a refrigerant. So basically that compares to carbon dioxide, which is 1, which is the ratio. So the regulations are coming, which will move from a high GWP refrigerant to, I would say, a mid GWP refrigerant of 677. We looked into natural gas leakage too, and we have used some studies that have been posted about how production level emissions are there for every state based on the end use consumption, estimated consumption. So we used those numbers, and we also took some number for post-meter leaks, in the sense that, like, if behind the meter, after the natural gas meter, there are some leaks in the houses because of threaded joints or whatnot right there. So there was an assumption we took to estimate the natural gas leakage from furnaces when you're doing the comparison. And this is the Cambium data set that I had mentioned. So I just briefly, like, this is gives us an hourly forecast from 2022 to 2050. Well, that was when the study was done. It was published last year, this study, and we have used this 2021 data, and we had categorized the emissions from the installation of the heat pump, which will lead to grid side emissions, using this factor which we have used, Vendel Cambium set. And that's the goal. That's we have come up with what we thought was, like, big surprise for us, that, oh, this is obvious. Heat pumps make a lot of sense, because even though we include all the different types of emissions, because the building loads are high and all the leaks associated with natural gas are very high, it totally makes sense to install a heat pump just from the emission perspective, total overall emission perspective. And I should mention that these emission numbers are for the entire operation of the equipment. So it might not make sense in some places in the Midwest to install a heat pump, and it will be where we're getting a positive emissions, because right now when you install it, the grid might not be as clean as it would be in 10 years. But if you install a heat pump, the thing, or a furnace, the average life of the product or the equipment is 15 years. So the idea was that we calculate these emissions based on installation. So which is like when we did that for 15 years, average 15 years, and we look at this reduction, the amount of carbon dioxide equivalent reduction that we can obtain with heat pump installation is shown here. And pick the 6 different regions, what I had mentioned, and this is population weighted too, based on the county level population. And this was published last year, so which sets the stage for us to look into the other types of buildings, and so this is where I transition into commercial buildings, which is what we are looking into. And the problem here is that residential buildings are a lot homogeneous than commercial buildings. Commercial buildings are heterogeneous in the characteristics, like number of floors, square footage, number of zones. It is like, and also in the activity, what is the building used for? Is it used for food services, medical facilities, retail buildings, educational institutions like UC Davis? How many people are working? So it's like a huge variety what you can simulate. And lastly, it is hard to pin down the type of HVAC system that is being used. So heating, ventilation, air conditioning system that is in this, it was easy for us to do a furnace because there's in the residential, that's pretty much what is used. But in commercial buildings, there are different types of HVAC systems and mixture of natural gas and electricity systems, which I'll talk about. And it is just hard to pin electrification, how to pin down a actual or a typical baseline case for natural gas. So, which makes it harder for us to find the electrification solution for a building, commercial building. So it is important for us to characterize what is out there so that we could do a better job of finding an electrification solution. So we used the Commercial Building Energy Consumption Survey, which came out, the last it came out is in 2018. They have recently published the energy usage data. And so like we could, with that publishing, we could do something like, we can know, like, for example, something I did like very recently yesterday was to just look at what are the share of buildings which are based on the floors. And as you can see, it's hard to see maybe here, is the number of floors, the single floor buildings, there are a lot more of them than the like large buildings. However, large buildings will have larger loads, heat loads, and larger emissions. But just to get a share of number of buildings across the United States, we can use this data, the survey data for that. And although we have been talking about space heating, I was curious, is space heating really a problem in commercial buildings? And it turns out it is. It is. Space heating takes out about 1/3 of the energy usage in a building. So you can imagine that if somebody were to put a natural gas equipment in the building, that the consumption of that is larger than any of the other end uses in a commercial building you'll see. From there on, the question was, okay, so what about the different fuels that have been used? And you can see that and you can see the colors there, which denotes the different types of end users that are shown here. And predominantly, as we have seen in the residential side, natural gas is predominantly the source of space heating and fuel that is used. And there is some district heat and fuel oil and propane. There are some very small portions of that, but the big one is the natural gas. And then this is looking at the overall consumption of fuel. But then we look at, if you want to look at the main heating source by buildings, number of buildings, that's another way of looking at it. And you can see that, yes, by main heating source, if the source is looked at, electricity and natural gas are the two main sources of main heating source that we saw. The other thing that was interesting, I would say to me, was like, how does things change over time for buildings, for commercial buildings? So that's another information we have is the age of the building when that was constructed. So based on this, you can see before 1946, it was natural gas predominantly, and then electrification measures are probably coming up and space heating. There are times when there are more number of buildings, fraction of buildings where they're for using electricity and natural gas. But this is up to 2018 because the survey only goes up to 2018. They take like 6 years to process the data. So we are just getting the results right now. So going from there, so going a step down, we started looking into what are the heating equipment that you use. So try to characterize the problem so that we can find electrification solution to this. So thinking about the different types of equipment used, as you can see, the three most common ones are the electrical package unit, which is the rooftop unit, which I'll show a picture in a moment, and then a furnace, which we had analyzed before, and another one, the third or the largest one is the natural gas package unit, which is being predominantly used in buildings. So if I look at all the three different types of natural gas equipment for heating, space heating in a building, and if I further section it down into the age of the buildings, the big point that I had realized was that the natural gas rooftop package units are largely getting installed. So you can see this is the furnace, the package units, and the boilers are right here. And the fraction of buildings getting natural gas package units a lot higher in the recent years. So that's some revelation that we get from doing this kind of analysis, is that natural gas, although getting used, is in the form, it is getting used mostly in the form of package unit systems, which I think would be our first target. So for that, with that knowledge, we looked into an office building analysis that we had performed, and it uses the rooftop package units I just mentioned, and it looks something like that. They're package systems; they just drop on the roof, and it's super easy for them to be installed. That's one of the reasons they're getting more installed. But it is also easy to find a heat pump rooftop package units, and so we try to understand the implications of this kind of unit on the overall emissions, with the same way we have done for residential systems. In this, there are 3 floors we have analyzed, we have simulated, and we have simulated 3 gas pack RTUs, which is a rooftop unit, and 3 heat pump RTUs. And this building uses something called a variable air volume flow, which is basically, it has several zones. And so if the central heating is not running, or the rooftop is not running, it uses a reheat terminal to heat the specific zone, which is the electric heat. And it's lot lower efficiency than a rooftop package unit's compressor. It's just practically a toaster which just throws in heat. So we modeled all of this together. We looked into all these emissions, starting with the air handler fan emissions. We looked into obviously the compressor emissions for the heat pump. We've also included the the air handler fan for the gas furnace. We did the electric resistance tree pit, which in the both heat pump and gas furnace are used because, as I mentioned, in variable air volumes, there will be some reheating, which uses the electric strip heat. We use the end-use natural gas combustion. We took into account refrigerant leaks and also fugitive leaks that are upstream of the grid. So, for example, if it's a natural gas plant, there are NREL Cambium now also provides that information how much leak are there from just having natural gas being leaked before it comes to the power plants. So, and also included the natural gas downstream of the meter. Doing all that, we got this result, and this is using the Cambium 2021, which this is reduction basically. So you can see that there are some regions where we do get a negative reduction, or in the sense it's a increase in GHG emissions. And that's the main reason of this is that these buildings, these regions are very low heating loads. So what happens is that when there is a new equipment put in with all the refrigerants in there, and the equipment is not really providing or offsetting a lot of natural gas usage, the refrigerant charge emits over time, which leads to an increase in emissions in the buildings. So, so one of the things that we have seen, emissions per unit floor area of the office was an order of magnitude lower than homes. So the amount of natural gas usage per unit area is low. So that's why this kind of thing happens, where you have Pacific Southeast and Southwest of, like, where there's low building loads, we see this issue.
Can I just jump in with a quick
Yeah.
comment? So you talked about you showed an emissions inventory and refrigerant was like really small. My understanding, all the questions I've asked about the campus, and they get really squirrely. They don't have to report any emissions back to the state on refrigerant use in systems under 50 pounds. That's basically all space conditioning. So like if you put in a small packaged heat pump and you think about how much that might leak versus, because you have extra refrigerant in a heat pump versus an air conditioner, and that heat pump's not running very much because the heating load in the building is quite low, in theory you could lose. So
Okay, well then we need to improve our installation and our handling and maybe different types of heat pumps. I don't know.
but the other thing we could do is push the campus. You could easily track. Nobody really knows the number. Nobody really knows how much refrigerant we're losing from small systems.
Yeah.
So adding that to the list to question the campus on if they're tracking the refrigerant, because it wouldn't be that hard, practically
Okay.
speaking, but they don't want to.
Go for it.
Yeah.
Yes,
Wanted to make that point.
great.
And you have somebody online who would like to ask a question. Richie, you can take yourself off mute.
Hi, everyone. Good afternoon. Thank you for hosting this fantastic webinar. First of all, I am an Aggie, a proud Aggie. I was a 2018 graduate from the College of Environmental Sciences, the AgChem program, but I have since worked for the California Air Resources Board, help write some of the refrigerant regulations. So this topic is really, really pertinent. And I want to commend whoever just commented on the refrigerants, that the first thing is you can't manage what you don't track. So the first thing that the UC system needs to do is to inventorize all of your refrigerants better. There's a whole lot of very high GWP refrigerants in the UC system, not just used for HVAC, but also for refrigeration. So the very first thing is manage all of that, track all of that. 2, please don't take this transition to R32 as some kind of silver bullet. R32 is still a high GWP refrigerant. It just cuts down the GWP from 2000 to 700, but that's not the end goal. And some of the assumptions about leak rates, when I calculate what the leak rate is with a 15-year average lifetime after 15 years after the AIM Act, it's calculating out to an annual leak rate of 1%. That is unbelievably low. Right now, the average annual leak rates for residential HVAC are anywhere between 4 to 7%, and that's not the worst of it. Residential HVAC systems leak primarily at the end of life, when you retire the system, when you throw it out. Nobody really cares that the technician ends up venting most of it to the atmosphere. So your leak rates of refrigerants are not fully captured here. So let's be careful of that. And the UCs can sort of lead the charge on going low GWP in heat pumps. There are natural fluids that have GWP values under 10. It's just that there's not enough R&D happening in that space for residential applications. And we really look to, UC Davis and the Western Efficiency Cooling Center to do that kind of path-breaking research so that we can really maximize the benefits of building electrification. You're not offsetting any benefits from the refrigerant if you simultaneously tamp down the GWP of the refrigerant. So really great comment by the person who spoke just before this. Let's first manage the refrigerants we have, get our arms around what that inventory is. And then as we switch out equipment and move away from natural gas, which is an excellent decarbonization tool, let's also please be mindful of the refrigerant itself being a greenhouse gas. And that is a sort of mighty but overlooked climate lever. I don't know how many of you know this, but 2017, there was this consortium that published Project Drawdown, which is a list of climate solutions. And right at the top of that list, Project Drawdown in 2017 was refrigerant management as a really mighty climate lever. So I'll just leave it at that. But thank you for a great chat. And I'm happy to chat about this more follow-up. And I now work for a company where we actually help inventorize their refrigerants, big companies, as well as supporting governments doing F-gas policy. So just leaving that note, but thank you.
Yes.
Can I respond to that? I mean, both to Teresa's point and what Richie was saying online, I mean, it's really helpful. Campus doesn't measure everything that it should measure. When you bring that up in conversation, they don't like to be seen as not wanting to be transparent. And actually, I think many of the staff genuinely do wish they had better data to work off. I would love for a bunch of folks to give that feedback to the campus, like, look, you should manage refrigerants better, and we can help you with that, or here's how you do it. And just to give you a bit of perspective here, the plan to decarbonize the campus, 95% of scope 1 emissions by 2040 will be 65% of the buildings will be on a central district heating plant, or a couple of smaller plants for like a primate center. That's the proposed plan. The other buildings will be on individual, like commercial scale packaged heat pump like systems. And there's a whole plan for every one of them to be replaced. UC-wide wants to solve this issue by leaning into its traditional, oh, we can do more research, rather than actually also implementing their own emissions in-house. And what they typically tout is, hey, we can be a living laboratory. We can actually showcase how this is done in a way that you cannot do in the residential market, because there's all kinds of policy in place and codes in place that make that hard. So suggesting to campus, I mean, there's folks who've made a long list, is every single heat pump or furnace that we want to replace by a heat pump, and this is the timeline. I mean, that list exists with that level of detail. If we can get the campus to prematurely, or before we have to, go to a better quality, less polluting, less heating refrigerant, I think this is the place to do it. If it comes from people who actually have knowledge, like the people in this room, I think that the campus will be very willing to listen to that. And if you can connect me to Richie online, I'll make sure that she gets a copy of the link to give feedback when it is open.
Thank you very much. I will be happy to participate in that conversation, advocate for my alma mater to do better holistically when it comes to building decarbonization. I'll also be happy to connect you to the F-gas policy specialists at CAR, because there's state law that's gone in that'll require the use of reclaimed refrigerant above the GWP of 700 or 750 by after 2025. So there's a lot coming down the pike in terms of regulations also on refrigerants, for the exact reason that they get overlooked a lot. So I'm happy to participate in this, very much so. And I'll leave my contact information in the chat.
Sorry to derail you, Subhrajit.
No, that's all right. I think this is a very pertinent conversation. Yeah, it is. So as I had mentioned, it's definitely not the solution R32. It's just a transitionary refrigerant, just meets the code with less than 750. And I think we got the gist of this. And so the next step that we are looking into is like, we're looking at analyzing different types of building types. As I had mentioned, commercial buildings comes in so many flavors. So multi-story, we saw that single story is a very common type of building. So we should be looking into that. packaged rooftops that I just showed are the most common type of packaged units getting installed. So understanding them, what are the different challenges of them. Boiler systems, which uses the most amount of natural gas, like, that's how I haven't shown that. So in the entire US, we need to look into that. And then variable refrigerant flow, which eliminates all these emissions from natural gas, but also increases the refrigerant inventory, as we are talking about in a particular system. Just talking about the system, the refrigerant charge increases with the variable refrigerant flow. So understanding the leaks from that is also an important thing. And then I just mentioned improved models of refrigerant leak from various HVAC systems is also a necessity to understand the overall emissions. So I'll end here. Take any questions? Yeah.
On the switch to electric resistance heating in residential heat pumps, I saw the -18 degrees C temperature, switchover temperature corresponds to a cold climate heat pump. And would conventional heat pumps then switch to electric resistance heating much earlier? And also, how did you model the defrost cycle as to when ER heating would come on, defrost, because you need to know dew point in the air, the outside air dry bulb temperature and everything else. And finally, how did you think about electric resistance heating coming on when the heat pump is undersized, and also when it fails to anticipate a temperature setback aspect, where it's failing to sort of recover or reach the desired temperature quickly enough with the compressor alone, and it uses auxiliary heating with the ER strip?
Okay, so first one, like, it's a series of questions. The
Should we,
first
should
one,
we, would it make sense to,
yeah, you can, we
should
can.
we just kind of break, and in case people have to go, I don't know, it's 1 o'clock.
Yeah, it's already
and-
1 o'clock,
and
yeah.
grab some lunch and.
Yeah. Yeah.
Sorry, taking over meeting organizer here.
Did lunch
Yeah.
not come today?
No, it's here. It's
Yeah,
over here.
and I think people.
So say, well, yeah, why don't you guys chat?
Yeah.
I'll go eat.
Yeah.
Thanks so much.
Yeah, thank you. We can do it offline.